In this video, I'm going to cover the normal curve and calculating probabilities and percentages under the normal curve. In order to do this, I'm going to work through problem number 25 from chapter 5 of the textbook. This question states, IQ scores, or intelligence quotient scores, are normally distributed with a mean mu of 100 and a standard deviation, or sigma, of 15. Based on this distribution, determine various percentages and probabilities associated with various scores and ranges of scores. The first thing I want to talk about is what it means that the scores are normally distributed. Here's a picture of a normal distribution, or a normal curve. The horizontal axis represents scores, or x's, and the vertical represent frequencies. So each point along this curve corresponds to a particular score and the frequency of respondents with that score. Essentially, this is a graphical depiction of a frequency distribution, or what your textbook refers to as a frequency polygon. One of the most important characteristics of a normal curve, or a normal distribution, is that it is symmetrical. The line to the left of the midpoint is identical to the line on the right side of the midpoint. It also means that the mean, median, and mode are all equal and at the very center of the distribution. 100% of observations fall within the area under this curve. In the case of our example, the mean is 100 and the standard deviation is 15. I'll label this graph and indicate that the mean is 100. In order to calculate percentages and probabilities under a normal curve, we have to convert scores into standard scores, or z-scores. A z-score tells us how many standard deviations away from the mean a particular score is. And here's the formula for calculating z-scores. The only variables that you need to calculate a z-score are a score, a mean, and a standard deviation. The mean and the standard deviation are provided in the question, so all we have to do is input different scores into the formula to convert them into z-scores. The first question asks for the percentage of IQ scores between 100 and 120. I strongly recommend, when working on these problems, you take a piece of paper and draw a normal curve, and then shade in the part of the curve you want to find the percentage of. In this case, we want the percentage between 100, which is our mean, and 120. So I'll draw a line here and label it 120. And what we want is this area. That is the area between 100 and 120. The first step is to calculate a z-score, specifically to convert the score of 120 into a z-score. As the formula shows, a z-score is equal to our score, in this case 120, minus the mean divided by the standard deviation. I put the first two terms in parentheses because I want Excel to calculate the numerator before dividing by the standard deviation. The result is 1.3. This means that a score of 120 is 1.3 standard deviations away from the mean. Now, all we have to do is figure out what the percentage is under the normal distribution between the mean and a z-score of 1.3. We do that by referencing a table in the back of the textbook. In Appendix C, there's a list of tables, and the first table, Table A, on page 465, is the percentage of area under the normal curve. you'll notice that this particular picture looks very much like what we're looking for. And it says that the shaded area can be found in column B of the table. So if we look at the actual table, there are 3 columns. The first column is a z-score. Column B shows the area between the mean and that z-score, and column C shows the area or percentage beyond a z-score, as we can see here. Since the normal distribution is symmetrical, 50% of the area is to the left of the mean, and 50% of the area is to the right of the mean. If you add column B and column C for any z-score, you'll notice that it equals 50% because it captures all of the area between the mean and a score and beyond that score. In other words, 1/2 of the distribution. Back to our problem, we're looking for the percentage of IQ scores between 100, or the mean, and 120, which is a z-score of 1.3. Here is the z-score of 1.3, and in column B, we see that the percentage is 40.32. So from column B of table A, 40.32% of IQ scores fall between 100 and 120. The next part of the question asks for the probability of selecting a person at random having an IQ between those same 2 scores. Probabilities are mathematically similar to proportions. They range from 0 to 1 and are simply the percentage divided by 100. So the probability of selecting a person with an IQ between 100 and 120 is equal to the percentage of the distribution divided by 100. The next question asks for the percentage of scores between 88 and 100. So for this case, I'll draw a line somewhere to the left of the mean and label it as 88. And again, I'm looking for the area between that score and the mean. So this area. The first step is to calculate the z-score for a score of 88, which is equal to 88, our score, minus the mean divided by the standard deviation. This gives us a negative z-score, which tells us that 88 is 0.8 standard deviations below the mean. If you look at the table, you will see there are no negative z-scores. This is because, since the distribution is symmetrical, the area between the mean and some positive z-score is the same as the area between the mean and that score as a negative score. In both cases, we look to column B. So our z-score is 0.8. And here's the entry for a z-score of 0.8. From column B again, we see that the percentage is 28.81. The next question asks for the percentage of scores that are 110 or above. So I'll draw a line and mark it as 110, but in this case, we're looking for this area, the percentage at 110 or above. The shape of this area corresponds to this picture. We're looking for a percentage at or beyond a given score, and this can be found in column C of the table. So first we'll calculate a z-score, which is equal to our score, 110, minus the mean divided by the standard deviation, which gives us a z-score of positive 0.7, which is found here on the table. But this time, we're going to use column C, the area beyond z, instead of column B. So the percentage beyond a z-score of 0.7 is 24.20, which again is from column C of table A. The next part of the question I'm going to cover asks for a percentile rank corresponding to a score of 125. If you'll recall from a previous chapter, a percentile rank indicates the percentage that scored a particular score or lower. First, I'll mark a spot and label it 125. And in this case, I'm looking for the area that is below that score, which includes this segment and this segment. You'll notice that doesn't look like any of the pictures shown on table A. So we have to break this section down into multiple parts. Now this shape we know how to find. We can find this from column B of table A. So we'll start with that. The z-score for IQ score of 125 is equal to 125 minus the mean divided by the standard deviation. And if we look at table A for a z-score of 1.7, column B tells us that 45.54% fall between the mean and that score. This section is 45.54%. However, we also need to determine the amount in this section. Since this section is equal to 1/2 of the distribution, we know that 1/2 of the cases fall under that part of the curve. So this half is equal to 50%. To calculate this entire area, we simply add these two percentages. 45.54%, which we got from column B, plus 50%, which is the entire left half of the distribution, which gives us 95.54%. This means that someone with an IQ of 125 has an IQ that is equal to or higher than 95.54% of the population. In all of these cases, we start with an IQ score and look for a percentage or a probability. However, we can also look for a score based on a percentile. So let's say that I want to know how smart I have to be, how high an intelligence quotient I have to possess in order to be as smart or smarter than 99% of the population. In other words, what IQ is associated with the 99th percentile. Just as with the previous percentile rank question, I'm interested in this shape and I want to know what score is associated with 99%. Just as with the previous question, we know that the left side of the distribution has 50% of the cases. That means if I'm looking for the 99th percentile, that 49% is on the right side. In other words, this area is 49%. And the question is, what score is associated with that percentage? Essentially, I'm going to do the same problem we've been doing, but backwards. So I'll start by looking at column B in the table, and I see that a z-score of 2.33 is associated with an area of 49.01%. So the z-score for 49% is about 2.33. So now I have a z, and I know the mean and standard deviation, so I can solve this equation for x. So first I multiply both sides by the standard deviation. and then I add the mean to both sides. By solving this equation for x, I now know if I have an IQ score of 135, my IQ is as high or higher than 99% of the population.